a company is specializing in geospatial data acquisition, okay, and processing and many other things as well. Okay, so I'm very happy that Mr. Anomat accepted my invitation, okay, to share his knowledge and experience, okay, in the use of latest remote sensing and also GIS as well as BIM products, okay, in order to execute various kinds of projects, okay. So without wasting our time, I would like to invite Mr. Anomat, okay, to introduce himself as well as his company, and after that he's going to talk about the title for his presentation today will be on the integration of GIS and BIM, okay, by using multi-platforms as well as multi-sensor approaches. Okay, so without further ado, the floor is yours, Mr. Anomat. Okay. Before we start, can everyone please switch on the camera for us to record your presence today? This is very important for the record of the department, because when we have a professional invited speaker, this is an important activity for the department as well, because they always encourage collaborations with industry and so on. So this is something important for you as well as for the department. Okay. Everyone, please switch on the camera just for a few moments.
Semua kat rumah ni.
Kat college kan?
Kat college, okay, sorry. Okay.
Right.
Still tak boleh pergi kuliah
For this semester, they can still, for 3+0 subjects, they still can do it virtually. Except for labs, they have to go to the labs. Okay, they have to attend the labs secara physical. Okay, but for 3+0, they still can, do it virtually. So for this semester, I just finish everything virtually. But next semester will be everything back to normal. Okay, sure. Okay, yeah. Yes. Okay, just a few moments to capture the attendance. The cameras are not on. Is it because of my laptop? Semua dah on. Alright, okay, so thank you very much for your cooperation. So now I'll pass this session to Mr. Anomat. Mr. Anomat, this will be like 2 hours.
Okay.
Alright. Okay, so thank you. Okay, now
okay. Alright. Thank you to Dr. Helmi for inviting me to give some talk about, maybe to give you guys some experience, or to senang cerita nak story sedikit pasal LiDAR dan juga BIM, what we do here at Axis Gemilang. So almost I think Axis Gemilang since 12 years ago. Okay. Alright, I will share some of my slides here. Give me a few seconds. Okay, can you guys see this my PowerPoint? Okay, so I'm going to talk about geospatial and beam integration via multi-sensors and multi-platform approach. Okay, so my name is Muhammad Aitin. I'm Technical Director of Axis Gemilang Sdn Bhd. So you can find us at axisgemilang.com.my, and you can contact me below there. There's my email anomat@axisgemilang.com.my. Okay, or you can follow us at facebook.com/axisgemilang. Okay, so I always update some new info there.
Maybe they wonder, your name is quite unique. So Mr. Anomat is actually from Kedah, for the information.
From Kedah, and I'm a Siamese, orang Siam. We not call ourselves Thai. Thai is from Thailand. Okay, so we call ourselves Siam. Last time before Thailand exist, there is a country called Siam. Okay, kalau you guys pernah tengok movie Anna and the King, so you akan faham apa yang cakap lah. Okay, let's proceed. So again, follow us on facebook.com/axisgemilang. Okay. So next, okay, this is my presentation outlines. Okay, it's a little bit about me, and then about Axis Gemilang Sdn Bhd, and then I will talk about the LiDAR system, and then about standard LiDAR survey deliverables. And then I will show our LiDAR system, what currently that we have, and then I will show you some showcase what we have done this year. LiDAR survey at TP Hayun, Gunung Jerai, Yang Kedah, and then LiDAR and bathymetry survey around Puchong, Selangor, and then industry perspective for BIM. Okay. So a little bit about me. I'm graduate from UTM with Bachelor of Science in Sensing back in 2000. Okay, early 2000. So I involved in geospatial since 2001. I work at Malaysian Center for Remote Sensing as a contract research officer. At that time, we called MACRS. Now they already become agency Angkasa Negara. So short name is Angkasa. Okay. So at that time, I specialized in multi-spectral, radar, hyperspectral, and LiDAR. Okay. So I involved mostly in LiDAR surveys since year 2011, starting with terrestrial laser scanning. After that, mobile laser scanning, and then unmanned laser scanning, and latest is handheld LiDAR. Okay. The last few years, a lot of people talk about handheld LiDAR. So Google, you search Google, Facebook, or whatever, search on the net, you can find about handheld LiDAR. And I started to join Axis Gemilang back in March 2020, which I believe 2 weeks before they declare PKP. Okay. After that, it's almost 2 years without any activity. So just staying at home, doing some research and whatever. Okay. So next one. Okay. So if you guys have any question, you can always ask me. You can always interrupt me if you have any question to ask. Okay. So okay, now is about Axis Gemilang Sdn Bhd. Axis Gemilang is a geospatial company, exists since year 2010. Axis Gemilang is a subsidiary of Aquaspace Sdn Bhd. Okay, so the main focus for the last 12 years, mostly we involved in hydrographic survey, mostly in single beam sonar, and now we have a multi-beam sonar. Okay, and most of the the survey is done by our main parent, Aquaspace. Okay. So we start focusing on LiDAR technology and solutions since year 2017 when we use LiDAR technology to scan a riverbank at the Nukil, Klang. If you can see here, there's a boat and there's a LiDAR scanner here. Actually, it's a terrestrial laser scanner, a static scanner, but we combine with a unit of IMU, so it will become a mobile laser scanner. I will talk more about this later. Okay, so this is mostly our team members. Okay, we have about 10 of us here at Axis Gemilang, and you can always find us at the atmosphere at the back of Giant. If you come to Sri Kembangan. Okay. So a little bit introduction to Axis Gemilang. I prepare some video. Okay. So this is LiDAR data.
Can I see the video actually? Okay.
I'm sorry, sir.
Ouch.
Muhammad,
We couldn't see your video.
Pardon?
cannot see your video.
Tak nampak?
Yeah, you have to share. Yes.
Okay. Kau nampak
Yes.
Yeah, now
Nampak,
okay.
So if you can see here, now usually we use DJI Matrix 300 RTK for small area. So coming soon, we have P330 Pro. This is a VTOL main drone for larger area. Okay. Okay, let me talk a little bit about LiDAR. So LiDAR is come from a word, a short word for light detection and ranging.
LiDAR stands for light detection and ranging. A LiDAR system uses light energy emitted from a laser to scan the Earth's surface and record the heights of objects like trees and buildings on the ground.
So you can see what is LiDAR system. Is a combination, is a surveying tool that measure Earth's surface to produce data that contain that long and also elevation and other attribute like intensity, RGB, time, and numbers of returns. Okay, so if you can see here from the beginning, there's a ground. From this video, there's a ground. Okay, let me. There's a ground, okay, and there's a building, there's a stream. So we start to scan and produce a point cloud. Okay.
Surface and record the heights of objects like trees and buildings on the ground.
So you can see this is what was done through the integration of a laser scanner. If you can see here, this is a laser scanner, and then this is IMU, and then this is the GPS and also a camera, which is installed at multiple platforms, such as aircraft, nowadays drones, cars, or tripods. Okay. So if you can see here, there will be IMU, initial measurement unit. Why basically we need IMU? Because when this is a moving vehicle. Let's say drone is a moving is an aircraft. It's an aircraft, so it moves. Cars, we drive car, so it moves. So there will be there will be what we call a movement that will involve roll, pitch, and yaw. So all this must be corrected. So that's why we install there IMU to correct back all this information to make sure all the produced point cloud are very precise and accurate. Okay. So you can see from this picture, roll, pitch, yaw. Okay. Dia punya what we say in Malay, putaran, mungkin dia punya lengkukan dia, okay, dan kiri kanan atas bawah dan pusingan dia. Alright, so this is a little bit about LiDAR technologies. Okay, so from the top is there will be a LiDAR instrument, especially on laser scanner, from airborne, terrestrial laser scanner, or mobile laser scanner. And then we will have a face-based LiDAR, and then we have a time of flight LiDAR. Okay. Okay, and then from here we have a discrete return LiDAR, and then we have echo digitizing LiDAR, and then we have full waveform analysis and online waveform analysis. The difference between two, one is is a post-processing, mean after doing data acquisition, we collect data, we come back and we do analysis at our own PC or workstation. Or if we use online sensor, everything is processed during the data acquisition. So why we choose a waveform processing? It will give you a more precise, accurate, and attribute-rich point cloud. Okay. So if you use only a face-based scanner, it will give you mostly a dense point cloud, very precise dense point cloud without any attribute information. Okay, if you can see here, can you guys see my mouse movement?
No.
Oh, tak nampak. Okay. Like this, nampak?
No.
Tak nampak juga. Okay, wait, let me.
Maybe try and enlarge kan dia punya tu PowerPoint.
Sekejap
Maximum.
give me one moment. Okay, let me share again. Boleh nampak sekarang?
Okay.
Can see.
Alright.
Play. Play
Yeah, that's better.
Tadi I just share. Okay, so this is an aircraft field. So aircraft we shoot a beam, a light. So it's going through the maybe the forest. Okay, and this is a footprint of the laser scanner. So every time it hit the laser scanner hit something, it will return back to the scanner. Okay, and it will produce some waveform. So this waveform will be recorded as a waveform, and then will be processed either using offline or online. Okay, and then later we can analyze this data. All right. Okay, this is some of LiDAR platform. So this static laser scanner, this is mobile laser scanner, this is airborne laser scanner, and this is we are using drone, unmanned laser scanner, and the latest what we call a slam LiDAR. Okay. Let me go back here. Okay, different scale of LiDAR application. Let's say you want to scan the entire, in this example, Gunung Jerai and the surrounding area. So it best to use airborne laser scanner installed either on fixed wing aircraft or any helicopter. Okay, but let's say if you want to scan road to detect a road condition or to just to map a road and maybe something beside roads or for road maintenance, so you can use a mobile laser scanner. And let's say if you want to scan a house, office building, or very small area, a slope, let's say there's a slope failure, then you want to scan to come out with maybe terrain model or to do some geological analysis, and then you can use a terrestrial laser scanner. Maybe this one is suitable for a very small area, maybe 1 hectare or 2 hectare. So let's say you want to scan a little bit of maybe area of Mount Jerai, and then maybe you can consider to use ULS, unmanned laser scanning. Okay, and then this is our standard LiDAR deliverables. We give you a colorized LiDAR point cloud in local datum. Usually surveyor will ask in Cassini. Let's say a researcher will ask us to give them in RSO. Okay, and the standard deliverables usually we give you in UTM 47 north, UTM 47N north. Okay. And then we produce a mosaic orthophoto with minimum 5 cm to 15 cm GSD. GSD mean ground sampling distance. Mean the highest pixel yang kami boleh bagi, we can give is 5 cm. So let's say we fly at maybe 50 or 60 meter above ground, then we can give you a 5 cm GSD. But let's say if we fly about 100 meter and above, maybe we can give you around 15 cm GSD. Okay, so it's depend on the flying height. And then from here, from the LiDAR data, we produce a digital terrain model, what we call DTM, also with 5 to 15 cm GSD, depend also on the flying height. And then we give you a digital surface model, DSM, also the same 5 to 15 cm. And then others is we give you contours in shapefile in GIS format. And usually customer will ask for what we call a 3D fly through. The 3D fly through is just something like this that I share with you. I show you a few minutes before. Something like this. Okay. Okay, this is what we call a 3D fly through. Let's say if they want to do some presentation like this, or they want to show to maybe someone is not really technical, maybe to some layman or minister or pegawai daerah or whatever. Let's say disaster hit Gunung Jerai, so Agong plan to visit there. So maybe he won't know a lot about technical. So what we can do, we can create something that he and other people to see or to visualize what is happening around there. So I'm going to show later. So what we did with UTM and JMG, somewhere in the place called Titihayun Gunung Jerai. Last back in 2021, there's a phenomena called I don't know what they call it in English, but in Malay they call kepala air. Okay, so this disaster, I think is happened around Gunung Jerai, and affect a few of the area affected. Okay, so I'm going to share you what we have done over there. And then this is our technical spec on our LiDAR system. So if you can see here, our LiDAR system absolute accuracy. This is a general system performance. We talk about absolute accuracy is when we combine with base station data. So when we capture data, usually people be asking for absolute accuracy, the data that we corrected from the JUPEM benchmark. Okay, so what is the accuracy that we can the most accurate that we can give them for horizontal? It can go up to 10 centimeter. For vertical accuracy, elevation, we can give up to 5 centimeter. Okay. So, and at this accuracy is achievable at 50 meter flight altitude above ground level. Okay, and this instrument weight around 1 kilo. Okay, and then data storage is about 256 gigabyte. Okay, so the most important is point density. So if we fly this UAV at 5 meter per second, or 18 kilometer per hour speed, the speed of the UAV, then at 50 meter you can get 570 point per meter square. So this is a lot. So, and we can get about 280 point per meter square at 100 meter AGL. So let's say a normal flight with aircraft, usually we produce about 8 to 10 point per meter square. So you see how wonderful the data is when we use UAV, or we call ULS. Okay, so by using this scanner and installed on top of our Matrix 300 RTK, we can cover per takeoff is about 2 kilometers square, approximately about 30 minutes of flight. Okay. So we use a laser scanner class 1 Okay, class 1 is harmless to our eye. There will be this is what we call a near infrared laser, so it's harmless to eye. So some people use a green laser. Let's say you want to fly at 4 kilometer altitude using aircraft. Maybe they will consider to use a green laser. Okay, but when we flown lower, so usually we use a near infrared. Okay, maximum range reflectivity is about 450 meter. So for about 10% reflectivity is required about 190 meter. So let's say we flown at 190 meter. So anything that reflect about 10% of return of the energy we can detect. Okay. But if we flown at 450 meter, we need at least that object must return back energy at 80%. So the idea is when we shoot the laser, let's say the laser I shoot at a tree, and at that time I flown. Let's say I fly at AGL at, let's say, 300 meter. So maybe we can detect back 80% of the energy we return to the scanner. Okay. So the laser scanner itself, the accuracy is about 20 millimeter at 20 meter, and at 100 meter is about 3 cm. Okay. And the precision is about 15 mm. Okay. So the system also come with installed built-in camera. Is about 20 megapixel or 30 fps. Okay. So most of the scan rate that the most we can get is about 720,000 point per second. So this scanner will produce up to support up to maximum 3 returns. Okay, so 700,000 point per second is a lot. Okay, we need some scanning. I think near your faculty there. Even I have the data, and I already shared with Dr. Helmi, and you also have this data at your lab. Excuse me. Okay. So we also have Phantom 4 RTK for accurate photogrammetry mission. If you can see, there was this is a base station. Okay, for RTK, real-time kinematic mean correction. Mean when we have a base, so we can correct back with Jupyter benchmark. Okay. Okay, this is our I will call this our new baby soon. I think by next week we will have this drone. If not by maybe another 1 or 2 weeks, we have this drone. Actually, this drone already arrived about 2 months ago, but at that time it was sent to SIRIM for inspection. We need to get a SIRIM approval before we can use this drone. Okay. So the drone type is a vertical takeoff and landing. Okay. So the maximum payload that it can carry is about 2 kilogram, and the maximum takeoff weight is about 14 kilogram, including with the UAV itself. So the maximum weight is about 14 kilogram, and the maximum flight time without any payload, without any sensor, is about 160 minutes. It's about 2 hours. But I think with a payload, maybe it will reduce maybe to 140 or 150 minutes. Okay. So cruise speed maximum is about 21 meter per second. So the max climbing speed about 5 meter per second. Descent speed is about 2.8 meter per second. So you can see this wingspan. This drone have a wingspan about 2.53 meter. Okay, a bit lebar. And then vertical takeoff height is 50 to 200 meter. So the RTK accuracy of this system can go up to 1 centimeter horizontal, and also vertical is 2 centimeter. Okay, RTK accuracy. And then maximum flight altitude MSL for this drone is about 6,000 meter. So mean you can bring this drone to the Mount Kinabalu. You can climb up to the top. Mount Kinabalu is about, I think, 4,000 MSL. Okay, so you can start this drone and capture data there, no problem. Okay, that is mean what the maximum flight altitude MSL. So mean it can operate at higher altitude area. Okay, so mean you can bring it to maybe Mount Kinabalu or Gunung Tahan, maybe somewhere Mount Sangkudung, somewhere hilly area. Okay, so wind resistance is about 12 meter per second, and this one is do we require ground control points? No, the answer is no. If we activate PPK, okay, post PPK or this PPK or RTK. Okay, if we use PPK, is a post process. So after, let's say, we set up our base station, we collect everything, we come back and we process the data. We correct back with Jupyter, but at office, so what we call that a post process kinematic. Okay, if at site we call it RTK. We activate RTK, we call it real time kinematic. But mostly of the project, we use PPK. Why? Because some of the area maybe we don't have telephone signal, Wi-Fi signal, so we lost connection, we lost information, so we can't, so the data cannot be processed, so we prefer most PPK. Okay, until we upgrade the entire country to 5G or maybe later 6G, so I think we better stick to PPK.
Mr. Ahmad, so which one is better for your project, fixed wing or multi-rotor?
Actually, it depend on the area. Let's say, okay, I will show you. Okay, this VTOL can go up to 20 kilometer square coverage. Okay, so it will be equipped with multiple sensor, a camera, a normal camera, multispectral, and a LiDAR sensor. Okay, so how big is 20 kilometer square? This is how big is 20 kilometer square. You can scan the entire Penang Island. I mean, maybe about 95% of the island. So let's say if you have a big area like this, so use our fixed wing, our VTOL. But if you want to scan maybe a very small area, let's say less than 2 km square per takeoff, as I say just now, I say our battery is 300 per takeoff. Maximum coverage is about 2 kilometers square. Okay, so let's say maybe we can cover 2 kilometers square, maybe half of UPM. I don't know how many kilometers square UPM. Do you know, doctor?
You can measure using Google Map.
Maybe you guys can do that later. So I tried yesterday. I think it's far more smaller than 20 km square. Maybe I don't know, maybe 3 by 2 by 2 or 3 by 3. Okay. So one takeoff if we have this drone, one takeoff, it can cover entire Penang. Mostly about 95% of Penang Island. So then maybe the rest we can use our matrix, the small lidar system, and then we can cover the entire island. Okay. But this is when we talk, the coverage is about 20 km square, but mostly when we do the real mission, normally we won't set at 20 km square. There is a lot of factor that we need to count in, maybe wind speed at that day, maybe obstruction, maybe what else? There's a few factors, okay? Safety reason, and maybe the most important is the safety reason, and then maybe we can reduce it up to maybe one takeoff we cover about 10 kilometers square. So when we do 10 km square per takeoff, so maybe when we do 2 takeoff, we cover entire island already, entire Penang Island. Okay. So just now I talked about Mount Jerai. So we did some scanning with UTM KL with Dr. Kamarul. He's the pakar in geological punya assessment. Okay. So you can search for him. He got his Facebook also, Dr. Kamarul UTM KL. You can Google for his name. Yeah, he's very famous. Anything disaster now, last time they refer to one professor from UKM, but that professor is no more. So now he take over. Okay. So what we did here is a LiDAR survey at Titi Hayun, Gunung Jerai at daerah Yan Kedah. The project is sponsored by JMG, Jabatan Mineral and Geoscience Malaysia. Okay, so they are the expert, or they are the authority that do geological analysis. Okay. Okay, this is Keratan Akhbar. Genap sebulan tragedi kepala air Gunung Jerai. This is from 19 September 2021. And you see here, banjir kepala air dan banjir lumpur yang mengorbankan 6 nyawa dan mengakibatkan lebih 2,000 penduduk terjejas di beberapa kawasan di kaki Gunung Jerai. Okay, if you see here, there is what we call a debris flow. Okay, so maybe some of you after your PSM, maybe after your maybe you want to do a master for your postgraduate, so you can consider to do a debris flow analysis or whatever for your master or your PhD soon. Okay, you can come and find me. Maybe I can share you some data. Actually, I already share this data with someone from UITM. She want to do, I think, her PhD. So she want to do debris flow analysis. Okay, so she got her data soon. She will get her data soon. Alright, next one. Okay, this is a small area. What we call here, the place called Hutan Lipo Titi Hayun. Okay, so who has been there? Siapa pernah pergi sana? There's a place called Air Terjun Puteri Mandi. Okay, it's somewhere in daerah Yan. So if somebody from Yan, then I think you're better than me. Okay,
ada siapa yang pernah pergi melawat Gunung Jerai. Gunung Jerai is very famous nowadays.
Yes.
For tourism and so on.
But now, I think from back from 2021, due to this phenomena, I think less and less people going there. Okay.
You got resort over there, right?
Pardon?
You got resort over there in Gunung Jerai.
Yes, there's even along this Hutan Lipo Titi Hayun, I think there's a few there, but all is destroyed by the kepala air. I will show you soon after this. Okay, so the highest elevation for this is a cross section from Google Earth. From Google Earth, you can hit a path, and then you can on the path you can see the cross section also, but it's not precise or not accurate, but it can give you approximately about the condition of the cross section of the area. Okay, so it's about 453 meter at the highest peak at the near the air putri. I think the highest peak at air terjun Puteri Mandi is about 500 meter something, but we not going up to there due to safety reason. So we further down the peak. Okay. All right. So this is what we do. First, before data collection, we do what we call a static observation. So I think you guys have learned, surveying. So survey. So I think you know better than me. Okay, we do a static observation. We find a station tanda aras, or we call a benchmark, a Jepun benchmark, somewhere near Yan there, Pantai Murni Beach. Sorry, here. This is our benchmark here. So what we call we transfer point. So we bring two base station, one set up at Pantai Murni at the benchmark, and one more is we set up a base at the Hutan Lipo Titi Hayun. You can see here I mark with the red dots. Okay, we set up a few here. Okay, so this is my colleague doing all the setup and also flying the drone. Okay, and then after static observation, we set up a base station, and then we collect a few GCPs. These GCPs is become like a test point for us. Okay, excuse me. Okay, okay, test point for us, and then we start a data acquisition, and then from there we do a data processing, and then we do some result analysis. Okay, and for this data processing, we have what we call a two software. Is for a LiDAR software, and also for photogrammetry. So for photogrammetry, we use what we call a Bentley context capture. So to produce a mosaic orthophoto, we use a Bentley context capture, right? So okay, so this is a surrounding area. Some of the area at the Titi Hayun is a river. It's where before this disaster is just a very small river. So you see how the affected of the kepala air, everything is become a disaster. Okay, so this is how we take off. Next one. Okay, this is when we landing. So kita sambut dengan tangan ya.
Bahaya.
Somehow
Blade.
The pilot will slowly will make the drone slowly go down. Somehow, because we cannot find a very nice
Landing spot.
landing spot, so we need to do something like this. Okay,
High risk, high risk.
it's quite a high risk. So please don't do like this.
We are not professional to do that.
Yeah, actually basically we are not allowed to do something like this, but somehow we have no choice at that time. Okay, so there is some result and analysis. Okay, this is a snapshot of colorized point cloud. We colorize back. Basically, the lidar point cloud itself contain no color. You can only show is what we call in false color, but not colorized. Not true color. True color we need to combine with normal RGB camera. That's why we have RGB camera, lidar, and now soon we will have what we call a multispectral sensor. Okay, and then this is DTM. Okay, so terrain model, we remove all the vegetation and also building, and came up with what we call a bare earth model. Okay, terrain model. And then this is what we call a surface model. Surface model include with all the buildings, all the vegetation, what other object on the ground. Okay, this is surface model. So because some maybe surveyor or engineer may need bare earth, but maybe geologists also need some bare earth, but sometimes they also want to see the tree height. Forester maybe want to see tree height, or maybe if you want to calculate a debris flow soon, so you need to know the volume of the tree or to the tree height. Maybe you want to factor in all this information, so you need digital surface model. Okay, so this is mosaic orthophoto. We do this by using either Bentley context capture or other few software else that resemble almost the same like context capture. But context capture will give you a better result, especially on the building shape. Okay, it will produce a very nice shape of the buildings. Okay, so this is zoom in at this area. Okay, this is about 5 cm, and then we produce some contour here. You can see here there is a contour. Okay, so this contour I overlay with point cloud, so you can see here this contour is considered right. Consider betul lah. If you can see here, this is the contour we produce. The road is in the upper level, in the higher level. This is on the lower level. Okay, if you can see here, all this over here is all debris flow come from this river, from here. Okay, and also from here. This is a river from both sides, from the upper stream. This is somewhere in downstream. Here is upper stream. So here is downstream. So this along this we got what we call a few resort over here. So almost few of them are destroyed by the debris flow. Okay. Okay, this is contour. Okay, so this is a contour somewhere at upper stream, so we can produce a very nice contour there. Okay, so I'm going to show you some video here. So you see here, this is lidar intensity. Lidar intensity we can show what we call in a grayscale, or you can put any false color here. Okay, you can put any color scheme to represent a lidar data. Okay, this is intensity or elevation. You can put elevation height, so you will color will based on your elevation height. And then this one is what we call RGB. So we integrate everything back with the camera, so we produce a very nice point cloud with true color. So you see everything is in 3D, is contain billion of points. A point, what we call a point cloud. So this point cloud is a XYZ, is contain a longitude and latitude and elevation information. And beyond that, it come with the attribute like intensity, time, what else? Number of returns. Okay, it can show you which one is first return, second return, and third return. Okay, so if you want to know more about LiDAR, come and meet us here. You can always email me, or maybe talk with Dr. Helmi or whatever. Okay, if you want to show, you want to see a live data, you always can come to my office. I can show you, I can share with you. Maybe I also can share with you some data if you guys want, so you can view using your own software. You can LiDAR data can be viewed using either nowadays with ArcGIS. ArcGIS also can import LiDAR data with .las, the laser format, or any other software available on the net, like open source software. You can find, you can Google.
QGIS.
So, pardon?
QGIS.
QGIS, yes, QGIS. Also, you can view with QGIS. You can view with kejap. I sudah lupa nama software. Okay, you can view it also with context capture actually, or micro station. If you have a micro station, then you can view, you can open in micro station, and micro station will import last into to their own format and read the point clouds. Okay. All right. So, okay. So here is some cross section of the area. So mean if I have a data, I use a software, I want to know a cross section. Let's say you are engineer, you are tasking by your boss at site. Okay, they want to build something here. So your boss asking you, I want to know this cross section of this area. So you ask us to fly a LiDAR, get the data, and make a cross section. So you can see here, there's nothing much on the vegetation. So here maybe down here got some stream there, over there, and then other spot is almost forest area. Okay, this cross section at the middle stream. Okay, this is at upper stream. Okay, this is the cross section. And then from the software, you can calculate what we call a slope gradient, the angle. Okay, so sometimes geologists need this to calculate, let's say, to calculate the risk. Let's say if you have got a slope, they need this kind of information, and from this data they can determine a few factors. Let's say there's a rock fall, how many or how far this rock will fall. Let's say, let's say, if this rock fall on one spot, and the splinter of the rock, when the rock hit bottom, it will definitely have some splinter. How far this splinter will go off? It may hit homes, house, cars, or people around there. So if you go through all along Plus Highway, sometimes you can find a netting above the slope. If you can see, there is some netting. Why they put netting over there? Is this factor that so the geologists already help them to calculate the factor, the risk factor okay, after they calculate all these risk factor, they determine that this rock may pose hazard to the motorist. So they recommend the plus highway to put a net. So that's why you see somewhere at Bukit Lanjan, over there there will a lot of wired netting. It's very thick wired netting over there. Maybe along after the what they Terowong, Menora Terowong. Down there also I have there's a rock slope, rock mountains there are at the mountains there, the rock slope. So a lot of netting. I have doing some scanning work there after the Monara tunnel, after the Ipoh. And then over there we did some scanning using terrestrial laser scanner, and we produce some result for Plus Highway. Okay, actually from the for their consultant. Okay, there is one of my experience. And then we can also calculate a slope height. This also a very important factor to determine, let's say a rock falls and debris flow punya ni information. Okay. Okay. Let's see the path of destruction before and after disaster event. Okay. Okay. This is what we call a 3D fly through that I create using a LiDAR point cloud. But this one, to make a better one, sometimes we to make a better visualization, sometimes we may use a point cloud resulted from photogrammetry. Okay, if you can see here, there's a few chalet here, what we call a resort, a few owner here. So this is along the river. So over there is Hutan Lipo Titi Hayun. This is after disaster. We flown at this area before Chinese New Year this year. See the path of destruction.
Is there any logging involved?
Basically, there is no logging involved in this area. So what they say is just a hoax. I mean, cerita yang direka-reka. Totally runtuhan tebing yang pokok-pokok yang kat bawah tu sebenarnya bila pergi tengok dekat site is memang daripada runtuhan tebing. Tak ada logging. There is no itself is the city, kampung. I think the people will notice if there is illegal logging there.
So this is very important. I mean, for people like you who got the first-hand experience of getting the data.
Yes.
Okay, you know what is happening.
Yes, betul.
You got the data to back up your facts.
Betul.
Yeah.
Yes. There's only a rumors, but basically is the debris flow itself. You see how nice is the data.
Where is the origin of the what you call it, the starting point of the debris flow? Where is it? Is it at the top of the gunung right? Is it?
Yes, at the somewhere at the Titi Hayun punya ni sini.
So that's the point of origin.
Here, around here. Actually, more more upstream. Further up.
Due to heavy rainfall, isn't it?
Yes, due to the heavy rainfalls. That day, when we go there, we listen to the orang kampung punya cerita. So they say that day is very, what they say, something that never happened before. The rainfall, they say the rainfall, something yang mereka tak pernah nampak lah.
That is very interesting. Any questions from the student? They are very quiet. Maybe some of you from Kedah, or maybe you have visited Gunung Jerai, or maybe you are from this area. Ada orang Kedah kan sini kan?
Yes, my hometown also not far from there.
So, students, you have any questions for Mr. Anomat? This is very interesting technology. Actually, it's quite novel, isn't it, in Malaysia?
Yes.
So, lots of things that can be explored basically by using LiDAR and other combinations using UAV. So this one is for environmental analysis, for engineering also, definitely like what Norin is doing for the FYP also is she got the data from Mr. Anomat also last time, okay, after we flew over the engineering faculty. So similarly, you can apply that to other applications in engineering. There's a lot. I mean, they use a lot for the LRT, MRT project, right? Anomat?
Yeah, correct.
This kind of technology.
Yeah. When they conduct a preliminary survey, usually they will capture LiDAR do data LiDAR acquisition, LiDAR survey.
LiDAR especially is very crucial for civil engineering projects because they give you all the information about the structure, about the contours, digital surface model very accurately. You don't have to go to the field and do leveling anymore. So just imagine if you want to do the digital if you want to create the DEM or DTM for Gunung Jerai previously before UAV, you have to go there and do your leveling, so it's going to be like impossible. Maybe it will take a year, okay, to conduct this kind of survey for Gunung Jerai, the cost and also the risk. Now you can just fly a UAV and after a few weeks, you can get all the data you need.
Yes, correct. Even now JMG is planning to scan the entire mountain. The entire Mount Jerai. So the tender, I think by next year.
Okay, it's good.
They're going to produce what they call a risk map over there, so they can start to calculate which area is very, very high risk.
So you will fly over the entire Gunung Jerai?
Too bad lah.
If I win the tender.
Any question? Any questions from the student, or Dr. Alia is here?
Yes, Dr. Helmi. I have a question.
Okay.
Hi, Encik Anomat.
Hi, Dr. Alia. How are you? I tak sangka you ada.
Thank you for your presentation. It's very interesting. Encik Anomat, I would like to ask.
Harap you faham lah.
Faham.
Faham lah. You faham lah. Student you I tak tahu.
From the
keep quiet.
From the data acquisition, the date of the data acquisition starts until your end product, how long does it take? I mean, including the processing, dan semua tu.
Basically, let's say the area is very small. We can produce within maybe 1 or 2 hours after that, because we can do on-site processing.
Oh, that's great.
That's why it's very important. Let's say a disaster hit, then you need very fast data. So let's say disaster hit somewhere in Kajang tonight, then you call us from let's say I say yes, then we go there and we do data acquisition, and we can produce that within an hour.
Oh, as if the area is about Kajang size lah.
Maybe smaller than that.
Oh, okay. So meaning the data processing depends on the size of the area as well.
Yes, correct.
Okay.
The smaller the area is quite small, then maybe we can done maybe within hours. If let's say a middle, maybe 10 km or 20 km square, maybe half a day. Okay, it depends on what you want, either DSM or DTM. If you want just the DSM, maybe we can give you the LiDAR data itself is considered DSM. Okay. Yeah, yes. So we can give you after we process the data ladder with the base station data, and then you can give you the raw data, mean without any processing, and then from there you can start to maybe cut cross section, see analyze the section or whatever that you want.
Mm-mm.
And maybe if you want DTM, a bare earth model, and then we need some more times.
Right. If let's say like I think the latest disaster, the one in Jandabai, right? So what do you think about that area? Is it like almost the same condition as Gunung Jerai, or it is a slightly different kind of surface, so it requires more timing for that?
I am not sure how big is the area. But if the area is very small, I think even this area, but due to we need to climb the mountains. This I mean this Gunung Jerai. It takes us about a week or so because we need to climb up and down because due to the takeoff reason. But I believe if we already have the P330, the VTOL,
Mm-hmm.
we can finish it within a few hours.
Oh, okay. So it means
The
that the
data can,
accessibility for the starting point and the landing point and so on for the UAV lah.
yes,
Right.
correct. It depends on the takeoff point. Yeah, if
Hmm.
you have takeoff point, then we can do it much faster.
Okay. Great, great. That's all from me. Thank you, Mr. Nomad.
Yes, thank you, Dr. Alias. Dr. Alias, sorry, Alias pula.
Boleh juga.
Boleh juga. Okay.
So you use context capture also in this project, eh?
Yes, to produce autophoto. In fact, you can produce what we call a reality models. I mean, you can build all the point clouds or photogrammetry. That point cloud generate from photogrammetry. Um, in context capture, even you can import a lidar data through the Bentley context capture. No problem.
Okay, that's good.
So, any
Yeah,
further question?
students are very quiet. I don't know whether they are still here or not.
Mungkin tertidur dah semua orang.
Okay, there is a question in the text. I call it in the chat box.
Uh-huh. Check box So mana lah? Uh, did you have any experience processing the data for flood mapping? I would like to know more. Okay, data for flood mapping. Okay, for flood mapping, usually is the same in this case. In this case, is the same. You see, we produce what we call DTM, and from DTM we give you the data. We give researcher the data. So this researcher we do all kind of analysis like debris flow analysis, flood mapping. Mean they simulate which area, let's say when raining, which area first will inundated, and then maybe they come up with all kind of risk map. Okay, I will show you in the next slide, uh, before and after. Okay, you can see here. Okay, this is before 14 March data from Google Earth. Okay, I overlay with our autophoto mosaic. You see, you can't see the river before that, but now the river has become so widened.
This is very interesting.
You see, 55 meter, 20 meter, 70 meter kelebaran dia.
You can see the destruction.
Yes. So you can see over there I mark dah bangunan hilang So it is what we call a before and after the event. After 18 August, the event happened on 18 August 2021. Excuse me. So okay, there is a part on disaster part. What we do for UTMKL. But what I'm going to show you next is some info that we extract for some other purpose. Okay, what we call a forest matrix. This one is for not for JMD or UTMKL. This is for our own purpose, where from here we derive a canopy cover, leaf area index, and what we call a gap fraction. Okay, so from this data, we calculate what we call a canopy cover. So how much coverage, the canopy coverage inside this area. Okay, so it's the canopy cover is the percentage of vertical projection of forest canopy to forest land area. Okay, so it's very important. Let's say if we want to preserve our nature, what we call, let's say we want to calculate carbon. I think this information is very important for carbon punya information. And then we can calculate a leaf area index, and then a gap fraction between inside the forest. Okay. And then what we do a tree segmentation. So by doing this tree segmentation, we can came out with crown height model, CHM. Okay, so there's a larger value. So pokok yang tertinggi, the highest tree here is 72 meter. So we need to ask somebody maybe from there, or forester, or maybe somewhere from your faculty. Is there a tree that can go up to 72 meter? I'm not sure. Okay, so we need to verify this information. Okay, because I think the tallest durian tree also maybe 40 to 50 meter. Maybe this one maybe represent what we call pokok tualang. Pokok tualang is a very tall tree, can go up very high, but we need to verify this information. Okay, so after that we can do a crown segmentation. So mean we can from this information, mean the next step is we can calculate individual tree extraction. You boleh start counting pokok already with this crown. You computer akan detect titik tengah every this segmentation and came up with individual tree extraction. So from here we calculate about I think approximately about 3 to 4,000 in trees around here. Okay, this is the number of trees. Represent individual trees. Is represent in maybe different color. So if you want to calculate tree height manually, we have what we call a ruler that we can calculate manually. If not, you can use the crown height model. Right? Okay. Finish for TT Hayun. The next one I want to show you is a showcase LiDAR at bathymetry survey at Puchong Selangor. Okay, so we did some bathymetry survey at Puchong Selangor. So area of interest, this is the area of interest somewhere around Taman Meranti Jaya. Basically, we scan all these pools or this tasik. We did all the scanning because they did they did a bathymetry survey for JPS. Okay, this is a project under Aquaspace directly. So they also do some LiDAR data acquisition over this area. Okay. So again, these are the setup or project workflow for bathymetry survey and for LiDAR survey. Okay, so over here we have expert in bathymetry survey and also for LiDAR survey. Mostly LiDAR is on E, and a bathymetry survey we have a few hydrographer. at least 2 hydrographer here, okay, that have they have what they call they have competent punya ni certificate, okay, to do bathymetry survey. Even we just bought what they call unmanned punya ni boat, unmanned punya boat. I forgot what they call the exactly boat for them, but it's unmanned punya boat that contain a sonar that I believe they can also put a single or multi-beam sonar. So we just bought it last few months, including with the LiDAR system. So if you guys want to see, you have to come here, okay? You can make a lawatan to industry or whatever. I can show you everything, okay? But I set a day, give us a call, and then I can show you all these equipment that we have here. If you guys interested to observe, to see the equipment, okay? So again, for LiDAR workflow, we do static observation, set up base station, central point, and then we collect some GCP for become a test point, and then we do data acquisition, and then we process and we come up with result analysis. It looks simple, but over there, inside there, yeah, it's like hanky-panky. Okay. Some result and analysis here. This is a colorized data LiDAR. Okay, we produce a data LiDAR, and then we combine with the bathymetry survey. If you can see here, this area basically is about -30 something. Kalau tengok data LiDAR negative tu something wrong, but here we combine with bathymetry, so we can get a negative value. So mean it's a below MSL already. So this tasik kedalaman dia, I believe about I say one of the tasik can go up to 70 meter something. It's a bekas lombong timah. Somewhere. Pardon?
Very deep.
Yes, very deep. But I show you here at the middle only already 17 meter. So yang ini yang hari tu bomba mati 8 orang.
Oh.
Around here, around this, I don't know which two, tapi salah satu kolam ni yang meninggal tu, mungkin yang ni. So saya rasa yang ni yang paling dalam. Okay, so this is DSM from the data LiDAR itself. So this is DTM. Okay, this is combined with bathymetry. So you see negative 40 meter. Dalaman dia. Tapi yang ini is not multi beam. This is only a single beam, and then we extrapolate dia. So we can see it produce about negative 40 meter. But I believe if we use multi beam, we can get a more very precise data. Maybe up to negative 50 meter. Okay.
So, dia punya deep apa you call it kedalaman dia 40 meter maximum.
Yes. Very deep. That's why yang I suspect this one yang bomba tu mati.
Oh, scary this one.
Very scary. Sebab memang kat situ bila dah masuk dalam ada ni pusaran air yang akan tarik mereka masuk dalam. Okay. So it's very deep. So this data basically is for JPS. They do Harkov Pace do some project for JPS. Okay.
So the LiDAR data can penetrate up to 40 meter.
No, it's combined with a bathymetry survey.
Oh, okay. From the UAV boat.
Yes.
So dia panggil UAV. I don't know.
But this one, I think they survey using a normal boat. They install with single beam sonar, and they do this, okay. And then we combine with LiDAR and bathymetry survey, both data. So that's why we can get this type of data, LiDAR and bathymetry survey.
What's the purpose of the mapping?
I think there's a tender from GPS. They want to know depth of this
They will
area.
be surprised to see 40 meters.
Yes, definitely. Okay, sorry. Okay, this is the auto photo of the area. maybe for project Tebatan Banjir or whatever. I'm not sure about the tender name, but I believe something about the Kajian Banjir or something like that. Okay, because they not only scan this column, they only scan the river. They also scan the river somewhere around here, Sungai Rasau. Okay, alright. BTM, this is more check of the photo of the area. So this is a contour, okay, about 1 meter contour. Alright, so finish on the showcase. So I'm going to share you about LiDAR for building for BIM. For basically from industry perspective, basically from our own perspective, because I don't represent all the industry here. Okay, from Axis to Milan, what we have done at Axis to Milan. So how is LiDAR meeting BIM to disrupt various industry? So LiDAR, as you know, we give a very precision built-in points density, all in 3D, very precise model. And then we not only generate surface model, but also structure like bridge, utilities. So we providing information about the structure in entirely. Okay. So we not give you only information about structure, but sometimes we can identify the condition of the pavement. Let's say there's a cracking on the road, so we can use this. Nowadays, even the government of Selangor claim they use AI to detect crack, the road crack, so they can immediately rectify all the what pothole. All the lubang on the road, they fly a LiDAR, then they use AI. So I don't know how they do that, but definitely they have some sort of procedure, SOP, that they do this. They scan the LiDAR, and they try to fix all these problems. Okay. And sometimes we use LiDAR. Let's say you scan a building, then you see a dark spot there. Maybe with naked eye you can't see. Let's say, but after you scan with a LiDAR, then you see there's a very dark spot there. Then you know there is a water seepage there. Okay, so you can suspect there is a water seepage. Then you can do something about it. Okay, so I believe BIM, you know better than me. So BIM is the holistic process of creating and managing information for a built asset. So like MRT corps, they build MRT railway, tunnel or what, everything. So it becomes their asset. Also how they manage their asset. Okay, so through BIM. Okay, so what is BIM used for? BIM is used for creating and managing data during the design, construction, and operation process. So BIM integrate multidisciplinary data to create detailed digital representation that are managed in an open cloud platform for real-time collaboration. So nowadays, you will find there what we call a digital twin. Some term mentally called digital twins, mean bangunan yang sebenar dan bangunan dalam bentuk digital. Okay, so you can manage the real building and also the model. So you can compare that. So maybe you can run maybe some simulation on the 3D models, and you can apply on the actual building. So and from there you also can set up maybe what we call under the term Internet of Things. You can set up sensor, but this sensor is connected with internet. That's why you call it IoT. Okay, Internet of Things. So because you connected with internet, so like your handphone, so you can connect with your friends, whatever nowadays. Okay, with internet. So you can make a video call with internet. Or something like that. Everything is IoT nowadays. Okay. So by using BIMs, give you a greater visibility, better decision making, more sustainable option, and cost saving on AEC projects. Okay. So this is the picture show the cycles of beam. Okay, so where is our capabilities? So at SC Gemilang, we provide accurate and safe data LiDAR within the project timeline. So we can produce about 700,000 points per second. So which again we have about 600 to 800 point per meter square in 3D forms. Okay, and we have a very impeccable give impeccable precision and accuracy. And again, we provide our client with a laser format that they can read, like a last LAS, .las or .laz, or if the client want everything in 3D models, okay, we give them in 3D models. Usually, maybe using Bentley MicroStation to derive all these models, or maybe AutoCAD, DXF, or DWG, and contour and also thin. Okay, and then this data can be imported and used in almost all the engineering and architectural software. Let's say like Bentley juga ada nama software this called like Lumen RT. Okay, so you can simulate everything in real life, macam betul punya ni. Okay, you can Google about. Okay, so where is our involvement in BIM? Okay, usually during the conceptual design. Secondly, during the construction, and then on the renovation part. So mostly we try to fit in ourselves in this part. Okay, so for conceptual design, we do for what we call a preliminary survey. We produce orthophoto, DTM, DSM, or we produce for visualization, or we call the reality models. And then during for construction, for monitoring phase or for to claim phase, so we can clone a LiDAR or orthophoto to help our client to make the claims. Okay, and then for the innovation, we can do a 3D modeling. We can do what we call a clash detection. Clash detection ni is something like, let's say you scan, let's say a tank. Let's say in oil platform, kalau siapa pernah pergi oil platform, there's a lot of piping. Okay, left and right, up down, a lot of piping go inside the tank. So somehow, let's say I want to fit in a new pipe. So when I do the scanning, I produce a model. So I try to fit in the model that the new pipe model. So I try to find the best place to fit in, or if let's say I want to put it in one place, then there is a pipe. So there is what we call a crash. So we need to remove it, or we need to move it at the other side of the tank. So that is what we call crash detection. And then for visualization, so sometimes we need to visualize. Maybe architect want to know the rooftop condition, or what is the floor plan, the cross section. So let's say every time you want to do some renovation, definitely architect will need all this kind of information. So the fastest way is to bring the slam LiDAR, the handheld LiDAR. So you go inside, just walk. Let's say last time what we did, 13th floor, I think 14th floor building, we do in 2 days with the scanning, and after that another week we produce the models. Okay, so you see how fast we can use LiDAR to produce the models. Okay, so again we can produce a floor plan or any cross section. Okay, and all this we can use either Bentley context capture, Bentley open roads conceptation, or Bentley Lumen RT. Okay, so I think Dr. ID, I don't know whether he already teach you about Bentley Synchro. So you can use a Bentley Synchro to monitor all the timeline, construction timeline, or the claim, or the costing, or whatever, using Bentley Synchro. Okay, MicroStation from design phase. Okay, And then open roads. Let's say you want to design, you have a LiDAR data, DTM. You want to build a new road, you can use this. Even they have what they call open rails. That one is for, yeah, railroads. Okay, and if you want to make a loop, in visualization, live visualization, kereta bergerak, train bergerak, so you can use Lumen RT. Okay, so this is, I show you guys some tutorial how we use a mobile LiDAR data and photo to produce what we call 3D models.
Context capture tutorial. 3D models with mobile LiDAR data and photos.
This one is using mobile LiDAR and photo.
Step-by-step operation. Step 1, create a new project. Step 2, add the images. Step 3, referencing and air triangulation. Step 4, import mobile LiDAR data. Step 5, import trajectory file. Step 6, create reconstruction. Step 7, submit production. Go to the photo tab to add your photos to the block.
So inside here is a context capture punya software. I don't know whether you have used before, but this is a software will look alike. So you just drag in all the photo inside here.
You can ask Nurin. Nurin is here.
Survey tab.
Maybe Nurin can share her experience in using context capture. Any questions, Nurin?
So far no. I'm doing the same actually in the video.
You met Mr. Anomat before?
Never met, but I've emailed before.
Email and WhatsApp lah.
So, Anomat, you use the context capture from our lab, right? So, how good is it in your opinion
I think the
for PIM?
context capture is far better than any other software like X4D and another one, what they call it, forgot the name. Especially on the building punya ni, apa nama, shape.
Oh, okay. That's
Okay,
good.
so definitely context capture will give you a far more better result than other software compare. Especially on the building shape lah. Building, dia boleh resemble the original building shape. That's far most important.
So, for the processing, you use what you call it, the data from the camera of the UAV or from terrestrial camera?
Basically, it depend on the project. Let's say if you want to scan a building, maybe what you can do, you can combine both of data set, either aerial or terrestrial. You can combine both and then let the software decide which one. The software will try to adjust everything automatically, and yeah, we try to produce a result. If not, there will be error, or the software will dismiss which part that which photo that maybe give maybe a bigger error, so we can define from there.
So, Nurin, in your work, you use UAV data only, or you also have data from your handphones?
I'm using both because the LiDAR data is on the UAV data is only for the top view aerial view. So it's not sufficient. So we have to top up it with terrestrial. And
So,
also the acquisition will be far more better if they are both done during the same day.
that's good. So, did you manage to create, the 3D models of the building at the faculty?
So far they have not all. There are some parts that are like error because they cannot find the lot of overlapping that I'm still figuring to like perfect the model.
But there are some buildings that you managed to get the 3D models correct.
Yes, mostly on the tower block.
Tower block, huh? Okay, it would be nice to see. Maybe you can show some of your results to me, Dr. Alia, and also Mr. Anomat. Okay, to comment later on, not today.
Right.
Yeah, it's a good thing to do.
Because last time I think Anomat, you have scanned the power block, right? Okay, so,
Yes, yes. Yeah. But I think she doing a great job by using her. She take photo from the ground also, because yeah, we not we only, yeah, we scan from the top only, so we did not scan from, I mean, from the side. So I think, yeah,
yes,
she's doing a good job.
okay. Because this will be one of the examples of the use of multi-sensor and multi-platforms, approach. Okay, to create
Mm-hmm.
BIM model, as well as I mean we can combine that with GIS later on.
Correct, correct.
Because I have mentioned about this to Dr. ID, and he's very excited about it. Because yeah, nobody has ever evaluated a context capture before. Okay,
I see.
because in the industry, you can see there are like only two players or three players on this 3D BIM. We have Bentley, we have AutoCAD. Another one, what's that? Yeah, but maybe other than Bentley, AutoCAD. I think AutoCAD. What's the name of the software? Revit or what?
Revit, yeah, Revit.
Yeah, Revit is. I mean, at the moment, they
Yes,
have lots. They have lots of users, I think.
yes.
So, but UPM got the privilege to work on, or they got the sponsorship to work on Bentley. We have to evaluate, and investigate how good Bentley is, okay, for this kind of work. I think in the US they use also a lot of Bentley, but in Malaysia, Bentley is not so popular at the moment. But this is what we have to do. I mean, basically to explore.
Yes, correct.
How
Maybe it's due to the pricing also of the software.
is it more expensive, Bentley,
Yes, definitely.
compared to AutoCAD or Revit?
Yes. Yeah,
Wow.
I think that is the constraint why people use less Bentley. If the
How
if
about
the
the features? How about the capabilities?
Grief capabilities is, I think, beyond expectation. Like you see, context capture we produce a far more better result than others. So I think the constraint now is about the pricing scheme lah, pricing scheme.
But in UPM, you can use it for free, because we have the license from Bentley. So since we are going to have the MOU as well, so the students also I mean, the students also can have access, okay, to UAV data provided
Yeah,
by.
they are very fortunate to have that kind of software. You see, inside there, thousands of Bentley software they can download, they can explore. So
And
we
also
should
from this
ask them to do every person one software to test out and came out with the project Sarjana Muda.
yeah, so that's why we have, for example, Nurul is working on it at the moment, and maybe in the future also we're going to have more, because we are in the process of finalizing the MOU with Aziz Gemilang, right?
I see. Yeah.
So maybe Dr. Alia will be checking the progress of the MOU. Okay. So once this is signed, then Aziz Gemilang will be able to help the students to have access to UAV data, to laser data, and so on. So I mean, we can generate a lot of research and also academic kind of collaborations
Yes.
pretty soon.
Once I've got the feedback, then I will update Dr. Helmi and Mr. Nomad as well.
Yeah.
Yes. Yes.
The process is going to take quite a while. I mean, I know much, so maybe
Yeah, it takes like so many stages and so much time.
yeah.
Sorry about that.
It's okay. It's okay. No problem. Take your time. Take your time.
Okay. Yeah. You can proceed. Ada lagi.
Okay, I think all this is just a formal punya apa nama step, how we want to process the data. So there is two here. One is how to process open word concept station to true. One is how to process a Bentley LiDAR.
On this Office tutorial,
So,
create a 3D model with
so
three
you can see
referencing
here.
and
This
air
is a
training.
step-by-step
Go
operation.
to the Photo tab.
How to be at the photo, and then how the software define the. I mean, sorry.
Put a mobile LiDAR create and reconstruction. Step 7, submit production. Go to the Photo tab to add your photos to the block.
So I just fast forward. Okay.
Go to the Survey tab to
I just want to give you guys how they do it, how we do it using context capture.
import control points to viewport.
So if you have a control point, you can download, you can import control points, mean what we call GCP.
Note that the photo block needs sleep reference.
Yeah, another thing is that I think some of the students also they might be working on projects related to hydrology.
Mm-hmm.
They may be related to geological analysis, slope analysis, and so on. So since we have a collaboration with Mr. Anomat, okay, we can also check whether we can acquire data, okay, for slope analysis, hydrological analysis, and so on, right? Anomat?
Yeah, correct.
Yeah.
Even I believe Bentley got a few software that specialize on that.
Yeah.
Flood,
For road, isn't it?
for road, for flood mapping, for let's say for slope start, geohazard. So
Mm-hmm.
I think it's good because we also can't explore everything. So maybe all you have about maybe 30 to 40 students. So if everyone explore one software, so I think
Yeah.
yeah.
Another thing I think is what is quite important is that the road condition assessment also is something very important, because I think this is very it is an issue, basically, like we have lots of accident cases and so on due to the bad road conditions. Okay, we know that the road conditions in Malaysia are quite bad, even on the plus highway, even though it is privatized, but still the conditions are quite bad with potholes, cracks, so many things. So I think JKR will need this kind of information to help them to take actions.
Correct.
Yeah, because I think every day we can see from Facebook or from social media that people got injured or killed, okay, on the road due to the bad road accidents, especially to the motorists, isn't it? So, and seems like the actions taken by the authorities are very slow, or maybe because they don't have the information.
Betul. That's why I think the Selangor government came out with under a company called Celgem. Celgem is a subsidiary company for government of Selangor. They do all the geospatial. I think they acquire the LiDAR data, and then they try to scan the road, and I think I don't know, maybe they say they will use the AI to identify all the potholes or whatever. So I don't know how they're going to cover the entire Selangor, but they claim they can do that. So
Surgeon, surgeon.
yeah.
We have UAV also.
I don't know they appoint who to do that, but if if they can do that, then it's very good. Actually, yeah, to be frank, because they say they use AI, but I don't know. Maybe someday I going to visit them or whatever to see how they do it.
And also JKR, we have some collaborations with JKR also. I think
Yes, it's a good thing actually. If we can come up with something and we can show them. But that's why we need to explore in terms of AI,
yes,
artificial
yes.
intelligence, how we can, let's say, automated this system.
Actually, it can be done because you can use, for example, deep learning technology, okay, to train the features, okay, to be detected. Actually, maybe we can do some experimentation and develop preliminary models, okay, to to do the AI, okay, for the detection, automatic detection of potholes and so on.
Yeah, correct. Even maybe if combine lidar with photo.
Yeah, definitely. We need to combine LiDAR and photo. I think the best will be to combine because from the photo alone, maybe it's not sufficient. If you have the LiDAR data, then you know the depth, the severity,
Yes.
severity of the conditions. Yeah, so that will be more accurate because you got the 3D model.
Correct.
There are so many things that can be explored. So we need to just plan properly, and also the students. There are so many things if you want to pursue your master or PhD later on. Data is very crucial. So once you have got the data, there are so many things that you can do with the data. So this UAV, RGB, multispectral, hyperspectral LiDAR, I think we can generate lots of data.
Correct. So this I think I'm going to fast forward it. So this is
Go to
what
the
they do,
Point
what they
Cloud
call,
tab and select Import Mobile Scan.
okay, they do what they call triangulation. So after produce a point cloud
Go
from
to the Point Cloud tab and select Import Mobile Scan.
so they import a LiDAR data.
Browse your point cloud and trajectory files.
Even for BIM, I can see that in terms of PhD research, it's still lacking. I mean, not many people are exploring issues in BIM. Also, BIM combination with geospatial things like that still lacking. I think it's still like a new area for research.
It's a new area even for research, even commercially. What I heard, we need to import workers from nowadays from Vietnam and for Philippines to do all the modeling, all the beam, because we lack of a student or people that emphasize on this solution. So I think, let's say if you guys, I mean the student, want to explore this new opportunity, also you can try to go into the beam side, okay? Beam as a beam modeler. I think the salary is, I think quite high. They say can go up to maybe 12K, 15K per month. So maybe you can look up for this to become a modeler, a beam modeler.
Okay, that's interesting.
Mm-hmm.
Any questions from the students?
I have a question, doctor and
Yeah.
minister. Actually, I want to ask that you have mentioned about a company that use this AI to check the road crack, right?
Yes. Yes.
So I would like to ask, how is the process that it integrate it to BIM, to BIM?
I think is a part of the information. Let's say if they scan the road and then after that they use AI, they identify all this pothole. Let's say maybe all this information about the road length. I mean the road apa nama the road condition. All we be act as attribute in the road information. Okay, let's say you do a terrestrial laser scanning, you go inside the building, you do the scanning, and then you use the AI, let's say, to identify, let's say, water seepage or maybe a crack in the building. So all this will become some sort like extra attribute to that building. So the next time when you go to, let's say, you go inside the building, you zoom in into that particular rooms, and then you click at that particular area. So there is information, or there is a crack over there, or there is a water seepage over there. So let's say you have this information, then you can instruct the joint building joint building board or your engineer or whatever or your contractor. Okay, please rectify this problem. Okay. So this is what very important when this kind of information that really important to we need this kind of information. So there is what we call what the term AI coming from. What how they do or how they explore is is their own method. Okay, like us, maybe we explore our own method. Maybe let's say you want to explore your own method. Okay, how I'm going to do I'm going to derive this information. Let's say I have a photo. I take a picture of a buildings. Okay, from this photo, okay, I want to use what formula, what kind of deep learning, okay, and then from there what kind of result that I want. So this is what you need to establish all this SOP.
Yeah, that's right. I mean,
Mm.
it's part of like if you learn about AI, okay, this is you need image classification as well as object detection, and then in order to
Mm.
develop your model, you need to have lots of training data. You have to train, okay,
Mm.
your deep learning model.
Mm.
So you have to capture a lot of data to train, and okay, and then after that, after you have trained based on maybe thousands or hundreds of data, then you can develop a system, that you can develop your system, or you can develop a software, okay, to perform automatic detection of conditions, okay, for building and so on. Maybe this is something new that is yet to be developed, okay. So
Mm. Mm.
it can be something novel, so a lot of potential for research as well as commercialization
Yes, correct.
later on.
So people is looking for this kind of solution. So this is your future over there. See, your future to explore as a student. You want to complete maybe this year already complete or next year already complete your degree. You want to you want to go to the market. So explore this opportunity. Learn a lot about BIM, about AI, about deep learning. And then I think you have a bright future. So because you see up there every year thousands of graduates nowadays. So everybody is competing each other. So equip yourself with all this information, all this knowledge, and then I think you can make a better presentation outside there.
Yeah. So any other questions from the students as well? Dah habis ke Anumat? You have finished your slides or?
Actually, okay. Context capture tutorial. I think I won't go further because I think this thing is kind of information you can always find on YouTube or you can just Google. You just Google. But if you need some kind of data, which I can share maybe part of it, if not all part of it, and then you can ask Dr. Helmi, or you can directly contact us. If I can share, then I will share with you. No problem. Okay. So again, okay, let me sum up my presentation. Okay, so thank you for this sharing session. So again, find us at Facebook /Axis Gemilang. I will always update new information there, new result. I will try to update. So I will try to make everybody keep up with this technology. Okay.
Okay.
Mm.
All right. So thank you very much, Mr. Anomat, okay, for your sharing session today. It has been very interesting. So we get a lot of knowledge and also information about the applications of UAV, LiDAR, RGB, and so on for a variety of applications. Okay, for natural disaster, for environmental, okay, for engineering also. So it's very nice, okay, to get all this information from you as an industrial expert. Okay, so after this, please don't be shy, okay, to contact Mr. Anomat. Okay, if you need any further information or data, we can always discuss. Because we have a formal agreement between UPM and also Aziz Gemilang. We are collaborating, okay, for our for our research as well as for industrial applications. Okay, so any last questions from the students? Don't be shy. Anything? Anything, Natalia, before we finish our session?